Hey all, we are at the time that this meeting is supposed to start, but we are a little bit low on participants. So if you have friends or colleagues who you expected to be here, check the participant list. And if you don't see them, please ping them. Make sure that they're aware that this is the time for the PPM interim meeting.
We're missing Alex as one person I think who needs to be here.
I just pinged Alex. He thought it was at 3, so hopefully he'll join in a second.
Okay, we're at 5 past. I think we're going to get started in the interest of time. So, welcome everybody to this interim meeting of the Privacy Preserving Measurement Working Group of the IETF. This is an IETF working group session, so the IETF note well applies. That means that by participating in this group, you incur certain obligations related to IETF processes and policies. That includes your behavior toward other participants, and it also includes some important binding legal obligations related to intellectual property. If you're not familiar with this note well, I recommend that you leave the meeting now and go review it, preferably with legal advice, before participating in the meeting, because by participating, you are bound by the terms of this note well. Part of the note well is about how we behave toward each other, and we have certain policies in place to make sure that everybody engages in an appropriate fashion. If you feel that you've observed a violation of the note well, please reach out to the chairs, ombudspersons, or any number of other people who would be happy to help you. This is a purely virtual interim. We're all in different places. MeetEcho's echo cancellation is pretty limited, so please mute your mic when you're not speaking. And generally, you should only have video on if you are actively speaking or presenting. And this is our proposed agenda. As always, the first thing we'll do is review the agenda. Does anybody have comments on that? Tim?
Hi, Ben. Thanks as ever for running these. So Chris Patton, that is,
You are muted.
I can hear him.
Okay. Did you hear? Benjamin, can you hear me now?
I can hear you as well.
Okay.
I can hear you.
Let's try again. Sorry.
Right, so everyone else apparently can hear me. Benjamin, is it working for you? Okay, good. So thanks as ever for running these meetings. Chris Patton was observing to me that besides the specific things here on the agenda, if there's time permitting, though, we should go over open issues on the draft and decide, do we want to do something about them and who's going to do it, and close issues as needed. So I'd be happy to lead that just by like sharing a browser window with the open issues on GitHub. And we can go through those, I think, after we hear about ECDH PSI, if there's time left.
Okay. Does anybody want to comment on that?
Just a quick other topic for Alex. He said he can be here in 45 minutes. So if his topic doesn't come up until then, so he apologizes for the interview conflict.
Thank you. That's right. Alex Koshelev has a partial conflict, so we may have to push his segment back, but we'll get there. All right. Let's start with Chris Patton.
Oops, I don't want to share my screen. I want to share slides. Where's the, okay. You would think that I've done this before. Ah, there we go. Okay. All right. Okay, cool. So yeah, thanks everybody for coming. So what I wanted to do today was, now that we're kind of landing the ship with DAP, I wanted to kind of go over the features that we have, different ways people might add features to the protocol later on, and also kind of give a history of the features that we rejected and why we rejected those features. Ships land sometimes. I appreciate when they do. Okay. All right. So for those who weren't around for the BOF, like I think 2.5 years ago now, our goal, we were thinking at the time basically just about client-side telemetry. So recently there was this big success for COVID-19 exposure notification like systems that would operate on people's phones. One thing that they wanted is like analytics for these devices, but they wanted those analytics to be privacy preserving, and Prio was deployed for that purpose. And years before that, like Firefox had already been looking at different ways of using Prio in their browser for their own telemetry use cases. And on my side, on the Cloudflare side, like we have there's other situations where we want client-side telemetry and we want to protect it, and we want to protect it. So things like web analytics platforms, network error logging, and so on. And then post-BOF, I think 2 additional use cases emerged. First being federated machine learning. So I think the first people to mention this idea, I don't know if people remember Olivia and Maxime from way back in the day, who kind of looked at how to do federated learning with Prio and also to add differential privacy on top of it. And that's gone a step further, which I'll talk about in a second. And then there's like more recently the PATCG folks. Now they're not a community group; they're a working group working on private ad measurement. One of their solutions is going to be DAP. Shan, what's a BOF? BOF is a. I'll try to watch the chat, but feel free to hop in the queue if you want to interrupt. BOF is the birds of a feather. So that's like when a group of people at IETF get together and decide whether they want to form a working group or do something else to solve a problem. Thanks, Ben. So what is DAP? DAP is a protocol for secure aggregation. So we have our measurements, and we want to compute some function of those measurements and return the aggregate result to a data collector. So DAP somehow is going to, is this cloud in the middle. It's going to somehow take measurements from clients and do some computation on them and give the output to a collector. And we want to make sure this is privacy preserving. One more kind of caveat here is that DAP actually allows the collector to sort of refine the data analysis to some extent by providing this thing we call an aggregation parameter. So how do we instantiate this little, this gray cloud? With secure multi-party computation. So to securely compute a function f, we're going to distribute the computation amongst two servers, one we call the leader, one we call the helper, and we're going to get privacy as long as these parties don't collude. So somehow we're going to cryptographically protect measurements so that we can do this computation on them and then return the encrypted result to the collector. So by protection here, we mean we're secret sharing the underlying data, and then we're encrypting that to whoever needs to be able to decrypt it to do some computation. So that's the very high level overview of what DAP is. And if you look at the spec, there's 3 big sections specifying 3 different interactions between various parties. So you have the clients uploading reports, basically their cryptographically protected measurements, to the leader. And then the leader interacts with the helper in this process we call aggregation, where we're actually taking the measurements, doing some computation to make sure they're valid, and then we're actually stuffing them in a database, shares of aggregates into a database to be collected later. And in the collection protocol, the collector interacts with the leader in order to get these encrypted aggregate shares. So yeah, so that's kind of the high level overview of DAP. One of the central notions of DAP is this idea called a task, which kind of specifies all of the parameters that are relevant to doing the computation. So this is like configuration for uploading, aggregation, and collection. The task identifies basically any parameters that are relevant. So for example, the leader and the helper have identities. They're both basically an HTTP server sitting somewhere on the internet that anyone can access, perhaps with some sort of authentication mechanism that's out of band for the core protocol. And then the clients and the collector are not identified at all in the core protocol. The kind of central MPC part is abstracted by this thing we call a VDAF, a verifiable distributed aggregation function. This is what specifies what you're actually computing. What are the measurements? What is the output that you expect? And then there's this concept called a batch mode. This is where we take reports and we partition to them into batches that we want to aggregate. And there's a variety of different ways you might want to do this. And this is one of the kind of extensibility points in the protocol. And then finally, each task has a bunch of cryptographic assets that are used for the computation. So we have HPKE for public key encryption, and then we have the VDAF execution involves something we call a verification key, which needs to be unique per task. Cool. So our core security goals we have basically 3. The first is basically it should execute the VDAF securely. And what this means is that we should have privacy as long as one of these aggregators is honest. So we imagine the attacker controls the collector and also one of the aggregators. So a very typical deployment is the leader and collector are actually controlled by the same entity, and the helper is there just to keep that entity honest. And we also want the protocol to be robust against malicious clients who might be trying to disrupt the computation. So because the data is secret shared, we need a mechanism to understand whether the underlying data is valid for some definition of validity. So for example, if you're expecting numbers between 0 and 10, we want to make sure that the data we're consuming are actually between that range of 0 to 10. Another property, it's kind of hard to, this isn't kind of explicit right now in the spec, but is we aim for what we might call task agreement. And this is weekly Basically, everyone should agree on what the task ID is in order to execute the protocol correctly. The task ID is going to identify the task configuration, so all of these parameters. But the orchestration of these task parameters and actual confirmation that we agree on the parameters is out of scope for the core protocol. And finally, we have replay protection. So we want to make sure that a report is only consumed at most once at any point in the history of the protocol's execution. So just to kind of call out some non-goals, we're not trying to get differential privacy from the core protocol. That is, the aggregate result might leak information about what about an individual's measurement, and this is sort of an unavoidable consequence of computing the thing that we want to compute. But there are mechanisms you can add on top of DAP in order to limit the exposure of any single measurement. And we also don't have Sybil attack resistance, so an attacker can sort of dump a lot of reports into a batch, and thereby learn a disproportionate amount of information about the rest of the measurements in the batch. And we don't have a mechanism in DAP to prevent this. Applications need to figure out a way to deal with this on their own. And there might be other security goals worth mentioning. None came to mind when I was working on this slide, but if anyone thinks of anything, just shout it out at some point. Okay, so how do you extend DAP? Well, the primary way, obviously, is to define a VDAF. So PRIO is kind of for general purpose aggregation. It's not going to give you every functionality that which you would want, but it gives you basically anything you could represent as, like, you know, encode each measurement in some way, add up these encoded measurements, and then do something with the results. That is that's compatible with PRIO. Now, PRIO doesn't give you every functionality you would want, and also it's not going to be the most efficient thing for certain tasks. So, for example, there's a VDAF called Pine, which Junier Chen has brought to the working group a few IETFs ago, if I remember right. And this is basically a VDAF that is based on many of the same techniques, but is heavily optimized for this use case of federated learning. So it's going to outperform PRIO 3 for this purpose. It just blows it out of the water. That's, by the way, not an adopted draft. There is an implementation. There is a spec being worked on, and it was something that I would love to see, IETF adopt in the future once we see adoption, once we see, people implement this and more eyes get on it. Another VDAF we've worked on is called Mastic, and this is designed to extend PRIO to solve a specific problem that was brought up in the working group. Basically, we have situations where we want to be able to group PRIO style metrics by client properties. And simultaneously, we don't want to have to expose what properties a report has. So for example, I want to be able to break down page load times by version of my client, but I don't want the client to have to tell me what version of the software it has, which is, kind of a not the best example. There's a better example is geolocation. So you want to break down page load time by geolocation, but you don't want to reveal in the report what my location is. So Mastic allows exactly that functionality. Again, this is not adopted. We thought of this as a replacement for Poplar. Poplar, it does everything Poplar does, but more. And but we haven't gotten as far as trying to do an adoption call. But again, there's an implementation. The spec is in pretty good shape and ready for folks to review. And finally, there is room for other cryptographic techniques in the space. So we have primarily function secret sharing. There's a link to, I'm not going to say what that is, but there's a link to a paper that kind of describes this. And this is sort of like, how do you get nonlinear data refinement into DAP? And function secret sharing is kind of the mechanism for that. So Mastic is based on function secret sharing, so is Poplar, by the way. And then arithmetic sketching, which is a generalization of what happens in Poplar, where basically you have a big vector and you don't know its size, and you want to do some input validation on that vector. And arithmetic sketching is useful in that context. And then something that was brought up way early on in the PPM days is this idea of doing implicit validation via like oblivious transfer and Boolean to arithmetic conversion, a la this paper Prio Plus. But this is not super well studied, so not something we have looked at closely yet. And there's probably room for doing more things here. Hopefully we'll see, as we see adoption increase, hopefully we'll see academics get interested in this topic and find ways to make improvements and solve new problems and so on and so forth. Okay. Now, if you one way to extend DAP is to define a new VDAF. Another thing you can do is define a batch mode. So the core document has two batch modes, basically time interval and leader selected. So time interval envisions this like sort of long-running telemetry systems use case. That's kind of what we were thinking about when we were thinking about, client telemetry. So think basically Prometheus, but with DAP. Wouldn't that be cool? And then leader selected is sort of, so time interval is kind of very specific. It imagines a specific kind of set of use cases. Leader selected is very, very general. It kind of maximizes flexibility of whoever is for whoever is orchestrating tasks, because you basically any two reports can go in the same batch without any restrictions. But this requires coordination with the leader. So it's not going to work with everyone, but this is like maybe the most general thing that you would need to do. And there's lots of space in between there. And we don't have any concrete ideas of different things we might want to do here, but in any case, the extensibility exists. And then there's report extensions, which basically modify the processing rules for reports. And we have a lot of examples of this. One is an adopted draft, which basically, the goal of which is basically to bind the task configuration parameters to the task ID, so that task agreement on the task ID implies that everyone actually has the same parameters. And this is basically strengthens this task agreement property that the core protocol wants to provide. And yeah, this just goes a step further. And I think a lot of people really like this feature. We expect it to be used quite a lot. And then there's a draft that looked at how to do Sybil attack protection using privacy pass. There's another draft kicking around that basically encodes DP privacy budget parameters so that you can do some sort of enforcement on those. And there's this is a very useful extension point. This is going to get used a lot, but just to warn folks, a document that, you know, like extending DAP to your use case, you might have define a report extension, but you might have to do other stuff. So one thing is defining a new batch mode, for example. And then finally, it's possible to like have a document that describes a new API that a DAP implementation might support. I think this is pretty easy to describe. So like, for example, David Cook has a draft that describes like APIs for doing interop testing between implementations. This is an extremely useful and important thing to do at a certain scale. If you have a lot of implementations of DAP, you want to automate the process of testing them. And you know, and this might be, you know, this might change. This might be like an alternative upload flow. It might be an alternative aggregation flow, and so on and so forth. So yeah, that's extensibility. We have new VDAFs, we have new batch modes, we have report extensions, and we have new APIs. So lots of room to do new things. Hopefully this covers, you know, any combination of things people might want to do with this protocol. So I just wanted to mention there's a few things still in the draft that we could consider whittling out. So one is so aggregation jobs have multiple steps. This is currently probably the source of the most complexity in the draft, and this is to support multi-round VDAFs. So Prio, Mastic, Pine, these are all one-round VDAFs, meaning an aggregation job is done normally for the synchronous flow is done can be done in one HTTP request flow. So something like Poplar, or in general when you're doing arithmetic sketching, you need multiple round trips over the network. So we could decide one round is good enough and cut out some complexity. I'm personally worried about that because there's things you can do with arithmetic sketching that you can't do with like the FLP that we have in Prio. And this may or may not be needed in the future, but I think to be conservative, I'm personally would be concerned about removing this feature. Another one is the aggregation parameter. Of course, Prio doesn't use this, Pine doesn't use this, Mastic does use it, and no one is using Mastic today, so this is in theory something that we can cut out. But here again, I would warn against removing this feature, especially since this one doesn't add as much complexity to the protocol. It adds a little bit because basically we have to make this distinction of when I'm starting an aggregation, when I'm starting an aggregation job, do I have the aggregation parameter or not? Which leads to two different kind of architectures that you can think of for DAP. So this is not without added complexity, but I would urge us to keep it if people think we can afford it. And finally, we could imagine removing batch modes altogether. Like I said, leader selected basically covers everything you might want to do. On the downside is that it pushes some kind of processing policy to the deployment, which may or may not work. And another note here is when you have a more specific batch mode, there are things you can do potentially to make the protocol faster or cheaper to operate. So again, something I would argue for keeping, but in theory, something we could remove. I believe this is the last slide. I think the history of DAP and PPM so far is removing features. We started off really not knowing what we're doing, and we were kind of going for maximum support of all kind of configurations we can imagine. And to make things practical, we've had to just remove stuff. And we've done that over a number of iterations. Very early, like there is the possibility we could have considered doing like general purpose MPC here. VDAF is like not all of MPC. It really does focus on a restricted subset of all different possible multi-party computations you would want to do. But we rejected that early on because general purpose MPC is very, very slow. There's other secure aggregation things we could have considered doing. I have a couple of links to different ideas that were brought up. There might be others, and I just couldn't find them when I was working on this slide. Next, multiple helpers. So we have one leader, one helper. Initially, we imagined there would be one leader and as many as like 3 or 4 or 5 helpers, kind of keeping kind of interacting with that leader and driving the computation. So the leader would kind of coordinate things in kind of a spoken hub topology. And this is interesting because it allows us to work in a weaker threat model where basically more aggregators can misbehave without things going awry. And that's pretty cool. But when we started implementing this, we knew quickly like, okay, this is going to make things a lot more complicated. It adds round complexity. There's coordination problems that like we just didn't want to have to try to solve. So I think probably after like 6 months, we figured out we should remove this. So like folks might remember draft 2, which in theory could have supported multiple helpers, but it wasn't implemented and it wasn't fully specified. So we cut that out. We cut that out a few drafts after. Another big battle was multiple collection jobs. So initially, it was possible to collect a batch multiple times, each time with different aggregation parameters. And this was envisioning sort of how you would use Poplar to solve the heavy hitters problem, where you want to know like what are the most frequently uploaded inputs among the set of measurements, and you want to compute that subset. This was a lot of protocol complexity, and when we started digging into like when we started scrutinizing this closely, we saw like a couple of different attacks we didn't know how to mitigate. We figured we could get away with this with some sort of mechanism for differential privacy, but that would have required analysis, and we still don't have a good DP story for DAP, which is a problem. And it's a problem I think this group needs to solve. But it is what it is. That would be a blocker for deploying Poplar. So given it just seemed still kind of a research problem, so we decided to cut it out of the protocol. And finally, folks might have heard of this paper called Whisper, which described this sort of optimization that we call batched VDAF preparation. And this is basically doing the sort of aggregation input validation flow across multiple reports at once. And this massively reduces communication costs, so it's a really nice optimization. But we sort of decided this has some unknowns with it. We'd have to figure out how to kind of deal with the case of when some fraction of the inputs are invalid, and so we decided to not deal with that problem, especially given that we can specify this in a future draft that basically defines a new aggregation API and potentially a new batch mode. But yeah, it's something that we can still do later on if we wanted to. So that's it. I thought, I was hoping this would be useful for new people. I think for folks who have been here the whole time, it sort of helps to kind of remind ourselves of what we can do with DAP. It'd be interesting to discuss if there's any features we want to remove. I know that the meta folks want to add a new API for doing bulk uploads. We can talk about how whether that should be in the core protocol or be in its own draft. But yeah, anyway, that's my time. I hope this was useful, and if folks have questions, go ahead and fire away.
Thanks, Chris. Could you flip back one slide? Thanks. Okay, yeah, so I jumped in the queue when you were going through this, just because you were going on the record asserting that we should hold on to these features despite not using them yet. And I want to say the same thing. I just want to add on the record that I think we should keep the feature set that we have, since we've gotten to the trouble of specifying it and indeed implementing it and deploying it. And in fact, in my view, the multiple step aggregation jobs, it doesn't add that much surface to the protocol. Like in terms of protocol text, it adds that you have to have aggregation job continuation. It adds complexity to implementations, I agree. However, it's worth noting that even if we end up with a DAP that spells out aggregation job continuation, even if we end up with a DAP that supports multi-round VDAPs, an individual implementation that happens to know it'll only ever do PRIO is free to just not implement, aggregation job continuation. So I think implementations, can make simplifying choices. It might be wise on our part to add something to I'm not sure which consideration sections is appropriate, but we could add a statement saying hey, if you know you're only ever going to support single round VDAPs, then you can leave this part out.
Thanks. I don't think it's necessary to say anything.
All right. Thanks a lot, Chris. Next up is Tim Gagan.
Thanks, Ben. Sorry, I was just finishing up notes. Also, thanks for pronouncing my name correctly.
No one is required to pronounce Tim's name correctly.
No, that's a must. It's a very firm, all caps in bold must. Okay, let's get started. So, as we've been discussing, right, we're at a stage where we feel like DAP is pretty well complete, and we'd like to move it along to working group last call, and the next steps towards getting like an RFC number, right? Yeah, so that's what I want to talk about today. There's various things over the lifetime of this document that I feel like we've been sort of putting off on or deferring, taking a hard look at. And in my mind, the notion was that like, well, there are sort of fundamental things about how this works that are still somewhat in flux. So it's not just yet worth it to expend the effort to get like really difficult about the spelling of certain things or the representation of certain messages. But at this stage, I think it is incumbent on us to do those things. In particular, what I want to look at today is aligning DAP with RFC 9205, which is also Best Current Practices 56, which is what's the title? It's like building protocols on top of HTTP. What's the slide say? Okay, we're not there yet. So there's RFC 9110 that describes HTTP, but that's sort of, I don't know, HTTP in general. So that document, of course, is relevant to DAP, but we are further interested in 9205, which has a lot of guidelines, if not rules, for how to design protocols. Okay, so before we turn to that, though, we need to recap a bit, like stuff that's happened in DAP recently. So the last time we met was in an interim back in October of last year. And since then, we have released, I think, 2, maybe 3 drafts of DAP. I think it's 12, 13, and 14. So there's been a number of changes that have gone into the document. There's a change log, in the draft that you can review, or of course, all the issues and pull requests are up on GitHub. But the headline changes that are of interest are what I want to focus on here. So as usual, we take changes to sync DAP with the most recent VDAP drafts. Often this is as simple as just like updating the string used in domain separation and cryptographic instructions, but also there can be, actual changes to the usage of the VDAP APIs. But the most substantial change that went in the recent drafts was that we specified asynchronous handling of aggregation jobs. So this is the aggregation interaction that Chris sort of recapped for us earlier in his presentation. So why did we do this? All right, so initially in DAP, we specified aggregation jobs as being a synchronous interaction, which is to say the leader sends a request to the helper does the VDAP math to service that request, and then synchronously replies. So we block on doing all that work. Our hope was that because the leader is free to schedule aggregation jobs of essentially arbitrary size, that the leader could simply tune the size of aggregation jobs to be small enough that it would always be reasonable to do this synchronously. However, having run DAP in production for a couple of years now, we've observed that there's a bunch of cases where this doesn't end up panning out. We have observed situations where aggregation job handling, despite your best efforts, can take on the order of minutes, which is longer than I'd like to hold a TCP connection open, and is also frustrating when you're trying to like define alerts for HTTP requests taking a long time. The reason this happens, it can be because you have particularly large measurements in certain pre-03 VDAPs. Like if you're doing really huge vectors or really big histograms, then the VDAP math can take a long time. But really what we encountered was that when you're running many aggregation jobs in parallel, they're going to want to record the output. They're going to want to record the recovered output shares that are the result of the aggregation jobs. And what that means is that all these aggregation jobs will often be contending for the same row of a database, right? Like, because they're going to be trying to increment that row with the value of the given output share. So what we experienced, when I say we, I mean in our implementation, Giannis, was that we would often see like many workers either waiting to take a lock on a database row, or we would see a lot of database transaction rollbacks because there would be contention on that one row. So of course, this led us to go do a bunch of like interesting and valuable database optimization and other work. But finally, we came around to realizing, well, the sensible thing to do here, especially in the face of like arbitrary potential future VDAFs, is to allow asynchronous handling of this work. So what went with this change also was some work to align collection job handling with these new semantics that were introduced. Collection jobs were already handled asynchronously in DAP, going back to some of the earliest drafts, because we figured that the collector would send a collection job, and then that would require that, depending on the VDAP and other factors, that could require the leader to have to run to completion an arbitrary number of aggregation jobs. And that would, could take long enough that it made sense for that always to be asynchronous. Okay, so a theme emerging here, right, is that we have things, some operations in the protocol that might take a long time, and we want to allow asynchronous handling of them. Yeah, all right, so keep that in mind. Okay, so the title of the slide deck, right, was about RFC 9205. So as I said, we're heading to WGLC, hopefully. So at this stage, I'm interested in getting really fussy about how things are spelled and represented. So in recent weeks, I've been making a number of changes to the document, just editorial stuff to try to clean up some text, to prune redundant examples, to tighten up the wording, because the document's also too long. So anywhere that we can delete things just to make it less of a meal for readers, I think is a good thing to do. All right, I've also been reviewing 9205 to see whether there are any of its recommendations that we should be making a point of aligning with. Okay, so for one thing, it spells out that you should, protocols that use HTTP ought to provide examples, non-normative examples of requests and responses. So on the right hand of the slide here, this is an example I lifted out of 9205. And indeed, for instance, Acme does this all over the place, and it is very helpful when you're trying to understand what's going on. So I'm planning to go and introduce this sort of thing into DAP. Another thing is that 9205 recommends using the broadest possible HTTP status codes in responses. So I have to acknowledge here that it's my fault, right? That DAP currently uses stuff like 201 created and 202 accepted in a few different places. I'm the one who advocated for these things because I thought it was the right thing to do, but I was wrong. And evidently what we should be doing is everywhere possible use the most general thing, right? So 200 for things being successful, 400 for client errors, 500 for server errors. And then if there's more specific, application level things that go wrong, such as say a proof failed to validate, or the timestamp in a report is outside of the acceptable window, then we have sort of in-band means, right, of representing that, namely an HTTP problem document with a sort of well-defined error code. Another minor thing is that so DAP is built on HTTP, but on top of that, we mandate HTTPS for integrity and for server authentication. 9205 tells us that there's a particular section of RFC 9110 that we should refer to, which has some sort of language on how to trust servers. And so at least we ought to have a reference to that. So all of these things, I hope, are one, not terribly controversial, and two, very straightforward. So my plan is to make PRs on the draft in the coming days and weeks that will achieve these things. And one thing I want to underline is that there, at least from this stuff, there should be no actual change to how the protocol works. Right, this will just be some editorial changes to the draft, and then we'll change some of the error codes, the HTTP status codes used in some places. But it doesn't actually change, the cryptography or what messages go back and forth. So yeah, this one's the easy part. All right. Now, let's flip back to the discussion of semantics for log running operations. Perhaps I have those slides in the wrong order. Oh, well. Okay, so DAP ultimately has several interactions that kind of look similar, right? We have initialization of aggregation jobs, continuation of aggregation jobs, collection jobs. All of these are, or currently are or can be asynchronous. There's also the aggregate share request, which is analogous to the collection job. So the collection job is where the collector instructs the leader to construct aggregate shares. To service that, the leader will turn around and ask the helper for its aggregate share. So yeah, there's a very strong analogy between a collection job and an aggregate share, which leads me at least to think, and I would imagine it would lead many readers of DAP to think, oh, this ought to work the same way. So what I want to achieve is to define a unified semantic for potentially long-running operations in DAP. I want to make sure that it's well aligned with the recommendations in 9205. And then I want to make changes to the draft so that we use that semantic consistently across our interactions. I think this will make the document easier to understand, less surprising. And honestly, I think it'll make things easier to implement because more of the API surface will sort of function the same way. What I'm not interested in doing, particularly at this sort of late stage in the lifecycle of this document, is reopen the discussion on whether we should have asynchronous handling of aggregation jobs. I think we did that for sound reasons, and the working group deliberated it at the time, and I don't want to get back into that conversation. I don't want to relitigate whether to use HTTP. HTTP, there's a lot of advantages to using it. There's some drawbacks, but I think it's too late to sort of envision stuff like doing this over gRPC or some other cool like streaming transport. As Chris pointed out, it would be completely possible in the future to say write new documents in this working group that like spell out an alternate, for instance, aggregation interaction that uses a different transport for HTTP. But for now, DAP is built explicitly on HTTP, and I don't want to change that. And finally, I don't want to change how this stuff actually works. This is really about the representation of messages on the wire and the spelling of certain things like which status code you use or the path of some requests. Okay. Sure, Chris, go ahead.
Sorry, are you saying you do changing wire formats is in scope for this work?
Yes.
Okay.
Yes. Yeah, changing representation of messages, but again, not like what they mean or what actual work a server might do in response to a message, right? So, all right, let's start by surveying what's in the current draft, which is draft IETF PPM DAP 14. So we're going to go through a sample of the existing interactions, and then as we go, I'm going to throw in my critiques, and we'll extract some observations. So we start with aggregation jobs, and here we're just looking at initialization thereof. So this is the request with which a leader sends to a helper to create an aggregation job. So it's a put request to a path containing the task ID. Okay, there's no cursor tool, so I can't show you what I'm pointing at. So, but anyway, excuse me. It's a put request to a path, contains the task ID and an aggregation job ID that's chosen by the leader. The content type indicates what's in the body, and then the body of the message is this encoded aggregation job init request. Okay, so far so good. I have nothing to complain about here. Now the response the helper will get, this can go two ways. As we discussed, right, there's optional asynchronous handling. So in the synchronous case, the response comes back. It's a HTTP 201, and the body will be aggregation job response. What's inside of that structure is an enum discriminant that says the status is ready, and then you'll have this vector of prepare responses, which is sort of the result of the helper having run that step of the aggregation job. However, if the helper wants to run the job asynchronously, then you still get 201, and you still get an aggregation job response, but the only thing it contains is the discriminants telling you status equal processing, and then there will be potentially a couple extra headers in the response. One of them is a location telling the leader where to poll for status of the aggregation job. And we have a should that instructs helpers to put in a retry after that suggests a polling interval for the leader. Oh, by the way, the example of a retry after here, it might be semantically wrong. I didn't actually go look up how you're supposed to express the value of retry after, but the example here is 300 seconds. Okay, so my gripes here are twofold, and I've sort of tried to color code them. Bear with me. So first off, as we were discussing before, the status code is unnecessarily specific. We should, use the more general thing. And we'll notice here that you don't actually need 201 in particular to distinguish what's going on. If it just comes back as 200, okay, that doesn't create any ambiguities. It doesn't complicate the leader's determination of what happened and what it needs to do next. The other thing is that it seems to me we have this unnecessarily elaborate representation of an empty response in the case where the helper is going to handle the job asynchronously, right? Instead of constructing a message that just tells you, oh, the status is processing, we could simply have no response body and no content type in the response. And this would be just as clear to the leader. But the advantage is the DAP level specification of what the aggregation job response struct is becomes simpler, and the construction and parsing of these messages also becomes simpler because you no longer have to look at an enum discriminant. Okay, so let's keep, Benjamin, go ahead.
Hi, Ben Schwartz as individual. this seems cool to me, but I think that what RFC 9205 is trying to tell you is that the server should be within its rights to return a 200 or a 201, that those should both be considered compliant behavior for a server.
Yes, that's an excellent point. Yeah, indeed. I think the problem that we have is that we're exclusively saying 201 is acceptable. Yes, that is a fair hair to split. So I think we'll have to check exactly what 9205 says and probably look at stuff like ACME, RFC 8555, yeah, to align with what they're doing. Okay, sorry, where am I at? Okay, so that's aggregation jobs. So let's keep those observations in mind. In fact, I'm going to return to them in a later slide. So now let's move on to collection jobs. Chris, go ahead.
What was your suggestion? Did you have a suggestion for the discriminator byte in the response body?
We just don't need it. I'm saying instead of like the way that this would work is you would still have, well, let's leave the status code aside. There would be no content type header and no body in the response. So yeah, which I think is just as unambiguous as the explicitly constructed response body. Okay, so moving on to collection jobs. So what we have here is, yeah, the request and response for the creation of a collection job, which in DAP is currently in draft 14 can only be asynchronous. So it looks a lot like aggregation jobs. Leader sends a put to a path that uniquely identifies the collection job. The body is this encoded creation request. And the response is going to be a structure that tells you, hey, it's underway, the status is processing. Yeah, the difference here is that there's no location header. That's down to a nuance of aggregation job handling where the helper has to tell the leader what step to pull for. I don't want to get into that because that interaction is kind of complicated and I think it's fine. I don't intend to revisit that. Okay, right, so my gripes here are essentially the same as they were with aggregation jobs. The status code is too specific, and again, we don't need a body that tells you like there's no body. We could just have we could simplify this in the same way that I proposed to simplify aggregation jobs. The other thing though that I think is strange is that while aggregation jobs allow you to go either sync or async, collection jobs seem to forbid synchronous processing. So I laid out, why we designed it this way in the first place. But at this stage, I'm trying to take the perspective of somebody who's never read DAP before, has not been in this working group, and maybe is sitting down to implement it. And this would just stand out to me as like, this is weird. Why is this thing different? They're both potentially long-running operations, but maybe it could be fast. And the object model of the two things is similar enough. So why not? Why is this one async only, but the other one is either way? Okay, so let's keep that observation in mind. Last interaction I want to look at is aggregate shares. So as I argued earlier, the aggregate share to me is very, very analogous to the collection job. Collection job is collection job is collector to leader. Aggregate share is much the same thing, but leader to helper. Okay, now in draft 14, the way this works is the leader sends a post request, and we'll notice here that the path only has the task ID in it. Let's keep that in mind. The body analogously to before is a request describing the aggregate share that we want, and the response is going to come back synchronously. It's an HTTP 200, and yeah, the response body is the encoded aggregate share. So this is almost the opposite case, right? The dual of the collection job case where we forbid asynchronous processing, even though, again, the reader I think would intuitively go like, well, why doesn't this work the same way as the other thing? So this is further complicated by the fact that the request path currently defined only has the task ID in it. There's nothing like a unique identifier for the aggregate share, which would complicate like asynchronously polling on the status of that thing. We also notice that it's a post request. The reason we did that is precisely because there's no identifier for the aggregate share in the request. So the sort of post, which is not understood not to be item potent, was more appropriate in that scenario. Okay, so extracting from all this, there's these three observations, right? One is I think we should conversion HTTP 200 everywhere, or actually taking in mind Ben's observation from a few minutes ago, Rather, the point is to remove the specific prescriptions for 201 or 202 or what have you. Two, I think we should be using empty response bodies and leaving out the content type header instead of inventing this new thing that tells you the same thing. And finally, and I think this is like the one that is potentially more controversial, I believe we should consistently allow either asynchronous or synchronous handling of operations across all these interactions. So DAP is built on HTTP, and I think we should lean into well-trodden conventions for create, read, update, delete. Good old-fashioned CRUD. Everybody hates CRUD, but it has survived like a cockroach for a reason. It's because it actually is well suited to a lot of problems, and I think that for all that DAP has this cool novel cryptography in it, this part of DAP or this facet of DAP is actually quite boring, right? And so we should, I think do the sort of well-trodden thing that will be less surprising to implementers and to readers. So what does this mean, right? Resources, we want them, I think, consistently to be uniquely identified by some path. And then we want them to support these 4 operations. So creation involves put to the path that uniquely identifies the resource. Now, if the server in the particular instantiation wants to handle it synchronously, then the response body is a representation of the resource, and content type is set to describe what it is. If it's being handled asynchronously, then there's no response body, there's no content type, and we'll have a should saying they're instructing the server to provide a retry after, suggesting a polling interval. Then to read, you do a get on that same unique resource path. So if the thing is ready, then just as before, you get a response body that is the representation of the thing with the content type telling you how to interpret it. If it's not ready, no response body, no content type, and a polling interval. Update operations are posts. Post is not idempotent because you're mutating something. So the use case we have for this is aggregation job continuation, where you're mutating an aggregation job by advancing it from step n to n+1. And finally, delete interaction, which we already spell out in a couple of places. So, same as everything else, just delete to the unique path. And this is a hint to servers that they can get rid of the referenced resource and, anything that they're holding on to that they need to be able to reconstruct it or work with it. And the exception here, right? So we talked about the aggregation interaction, collection jobs, and aggregate shares. The exception here is uploads. I don't see a reason to have to allow asynchronous uploads. The reason is that the upload interaction by design involves the client uploading to the leader, and then the client's out of the picture. And in fact, it's a very important property of DAP that the client speaks only once, right? Once the client has uploaded an individual report, it is not involved in the protocol anymore. And I think the protocol would not really be scalable or operable the way that we want it to be if that were not the case. So I don't believe that we need an asynchronous upload interaction. I suppose at some future time you could imagine this. Suppose you have a case where individual uploads are so big that uploading them in a single put request is intractable. If you're in that scenario, I mean, one, I might ask, are you maybe abusing Prio3 Sumvec? Do you maybe want to reach for a better tool? And two, I think that could be solved by essentially specifying something akin to AWS S3's multi-part uploads, where you chunk up this large thing you're trying to upload into multiple requests to make it easier to retry and manage. But that's something that, as Chris was arguing, you can imagine future drafts specifying alternate mechanisms for uploads. Okay, so what do these sort of observations and recommendations actually mean? What would have to be done to the document? So the aggregation job interaction, it's not terribly intrusive. I want to tweak HTTP status codes. I want to change some of the encoding of the messages to remove the status equals processing case, but no actual changes to how the thing works, right? For the aggregate share interaction, I want to add an asynchronous mode of operation that'll work just like asynchronous aggregation jobs. But it's a slightly more complicated change because we would have to choose some unique identifier for an individual aggregate share that the leader could subsequently poll upon with GET requests. I think the thing to do here, in every other case, the unique identifier for a resource is chosen by the HTTP client that's creating it, right? Leaders choose aggregation job IDs and collectors choose collection job IDs. So I think the thing to do here is to let the leader choose the aggregate share ID. The collection job ID that it's servicing is a natural choice, but we don't have to require that they be the same, I don't think. And finally, for the collection job interaction, you would just add complement its existing asynchronous mode of operation with a synchronous one. But again, there's no real changes to how it actually works. I would also add here that while I want to add some stuff to the spec, this doesn't necessarily imply that all implementations have to do these things. So suppose you have an existing implementation that does collection jobs asynchronously. You can just always do that, right? You can never respond to collection jobs synchronously. Always do them async, and you'll be perfectly legal and compliant with the specification. It does imply that like every HTTP client here, like if you're a collector and you want to work with an arbitrary leader, then you will need to support both modes of interaction, async and sync. But ultimately, I don't think that that's that much more code to write, to be perfectly honest, because like what's really of interest is at some point you get the response message and you have to do work with it. And so you'd have to wire up like doing that either in the course of doing like a GET request on the resource that you're polling on, or while handling the response to like the put request that you did to create the thing. Okay, I have a couple more slides that are about a different topic of unpredictable task IDs, but that's it. That's what I have on RFC 9205 alignment and consistent async or consistent long-running operation handling. So I think this is a good place to pause and go to the queue. Oh, actually, one more point to make, which is, so this is what I think we should do, and more to the point, like I intend to go do it. If the working group is cool with it, I actually intend to go and write the PRs on the specification to materialize this. Ben, go ahead.
After any changes related to this are done, I wonder what you think about repeating the HTTP directorate review, which was last done in draft 9.
Yes, I think that's a good idea. That also makes me think that there's a kind of a couple of other things related to HTTP that I'm sort of worried about. Like if we go to something like WGLC and start getting reviews from various IETF functions, that they might get kicked back to us. The two things the two things that I'm thinking of here are, first, like discoverability of the API or whether DAP needs a directory. So, if you look at something like Acme, the specification says that you're supposed to vend a directory, which is a JSON object that in turn describes where the specific different like API endpoints are. I don't think it's a good idea for DAP, in particular because I don't want to introduce one extra HTTP round trip when clients are doing uploads, which is going to be like a very high volume interaction. But I honestly don't know, like if we think that we're going to get, instructed to do this anyway, then I feel like maybe we'd want to get ahead of it. The other thing that I worry is lurking is request authentication. DAP currently just says that certain interactions have to have client authentication. And then we enumerate some requirements for that authentication scheme, but we don't mandate a particular one. So again, that's a design decision that I think is right, but I wonder if we might get instructed to, so I think what happened with Acme is they converged upon this scheme where requests like have to be this JWT construction rather than being, up to the individual deployment. So again, if we think that we're going to get like instructed to do that, then sooner seems better. But again, personally, I don't agree with either of those changes. So I feel like I'm a inadequate champion or advocate for them.
Yeah, I wouldn't charge ahead with either of those things before being told to.
And for the record, I'm willing to like do that work if it becomes necessary for the document to advance.
So I'm on board. I think the from where, so just speaking as an implementer, we don't have any plans to deploy the current draft right now. I'm hoping this would get done in a timeline where when we're ready to deploy something, we can just implement the next draft without having to be backwards compatible, because this is a pretty significant change. So if anyone out there has to maintain compatibility, like maintain the current draft or a previous draft alongside of this draft, your life might get harder. So I would just bear that in mind. Yeah, but if no one, I think if people have objections for that reason, they should raise them, and that might be a reason to not do this.
Okay, I'm going to reach into the chat here to surface an observation JC Jones made, which is that, quote, retry after on a 200 is likely to get a kickback. I think it did with ARI, which is a document going through the Acme working group at the moment. That's totally fair, JC. I wonder, do you know, is there an alternate header or an alternate construction that is more appropriate for indicating polling intervals or retry intervals? Feel free to respond in the chat if you prefer.
I don't think there's any better mechanism. I think it's just we are slowly evolving what that header is being used for faster than the HTTP working group was comfortable.
Okay, so then in that case, I think the path forward would be for me as the person who wants to make all these changes I'm going to go catch up on what happened in Acme, because whatever resolution they landed on, probably we could do. I also think that if we get another HTTP directorate review, as Ben just suggested, that this is something we could flag to whoever handles that and ask for some advice. Okay, the queue is empty. We seem to have achieved some rough consensus. Thanks, everybody. So to the chairs, I have like 2 more slides on a distinct topic, which is to do with unpredictable task IDs. Do you want to get into that, or would you like to go through other agenda topics first? I'm good with either.
Yeah, let's jump to the next agenda topic, which is with Alex Koshelev.
Cool, and I will come back to my last 2 slides later if there's time. Thanks, everyone.
You really are muted.
At least you can see me. Hey, everyone. I want to present the issue of supporting the bulk submissions in DAP. And I'm trying to share my screen, which I really don't know how to do this. Share my screen. I think I sent a request to share my screen. Okay, I don't think there is an option to do that. Oh, yeah, there you go. Can everyone see my screen?
Yes, we see it.
Perfect. All right, so let me just give a bit of a context, why we're trying to do this and what we are trying to do. So there's currently a working group in W3C that works on a private advertisement. And one of the proposals that is currently being considered leverages DAP for the private measurements of the advertisement campaigns. And the nature of the interactions between advertisers and users are slightly different from what the core DAP use case is. We often have a role of an intermediate that collects the reports from users, which can be impressions and conversions. The availability of that collector needs to be high because we don't want to lose those events. But what ends up happening is that at the end, a lot of reports, and we're talking about millions, are collected by a single entity, and they sit there together in a durable storage. And that collector entity wants to submit those reports for private measurements, essentially to DApp instances, helper and leader. They can't look inside those reports because they're encrypted toward DApp leader and helper, but they still need to be able to identify those endpoints and submit those reports to them. So I think it's possible to do now using the current proposal where we have an endpoint that takes an individual task or an individual report. However, it's slightly less efficient because there is a lot of fields in each report that are duplicated across those submissions. So that was what led us to propose the bulk submission functionality to DApp. And there is currently two design choices that we need to consider. One is adopt bulk submission as a core DApp functionality and include it into the DApp spec. And the alternative is to submit this as a DApp extension. This issue had a few people jumping in and discussing it. And at the end, I think we decided to see if there is if submitting it as a core proposal to DApp makes sense to this group or not. So there is currently a PR that is open. I haven't looked at Chris' comments there, but I will address them. And there is also, I had a conversation with Martin about how to do this uploads. One topic that is a little bit controversial to me, and I don't know exactly that I handled it 100%, is how to support partial failures. Because the nature of this interaction is that the collector carries, let's say, megabytes and megabytes, maybe even gigabytes of reports. And once it submits it to the leader, this interaction may fail somewhere in the middle. And we want to try to avoid submitting all of these reports again, because that will be just unnecessary and waste of the bandwidth, because those reports can be already committed to both leader and helper. So the current proposal essentially asks to enumerate those reports. Hold on, HTML, yeah. And just track them on the server side and report them on demand when clients come in and ask what's the status. But this maybe can be improved. So overall, we are looking for what we are looking from this group is maybe a consensus call how we want to do this, and if there is anything that is required from our side, we will be happy to work on that and help. The goal for us is to try to adopt this in any format because we believe the bulk submission will be useful for us and for us as a advertising company and for PPA as a spec. So if there are any questions, I'm happy to answer.
Okay, so I have some thoughts and observations. As I said in the issue, I support doing this in DApp itself. And principally, that's a question of timing. That's because we happen to not be done yet. We still have some window of time in which we can take changes. And this seems useful enough. And I'm optimistic that it won't be so hard to do, that we can get it in there. And the result would be, the alternative to taking this in the core DApp would be that Alex and others write another document, another working group document that spells out oh, here's a different way to do uploads. If we do that, then implementations may end up having to implement both things. If we could figure out one upload mechanism that services all the cases, I think that's a win for specification complexity and implementation complexity. However, what follows from that, though, and I think this has to be a design requirement of how we do bulk uploads, is that the case of a client, what we should support is that uploads may contain an arbitrary number of reports. And the current case, where a client is uploading a single report just means that you're sending a list of length 1. I don't want there to be a special case for single upload. and then another case for like a vector of reports. And my intuition is that this should be doable. But if we can't do that for like whatever reason, and it ends up having to be like two different sort of paths anyway, then at that point maybe it's easier to sort of work on this as like a separate document to not complicate the timelines of DAP. Okay, but like overall, I think that should be read as a statement of like support for doing this and doing this in the core specification. Okay, now what I hadn't thought about is, Alex, is the point you were just raising about like, what do we do about partial failures? So here I have like some questions to expand upon. All right, the section, DAP's discussion of uploads already actually, considers failure cases in the upload setting. And in particular, we make a point of allowing leaders to defer validation of a variety of things. Like the goal is we don't want it to be necessary for the leader to do things like say, decrypt incoming reports or do replay protection on the hot path of uploads. We just sort of say that like it has to be done by the time you run the aggregation job. So what that means is that there's any number of like things that can go wrong during the upload path, right? That we don't necessarily want to handle there, like cases where we allow the leader to tell the client, no, it was fine, but in fact, the report gets dropped. So the clarifying question, Alex, is the partial failure modes that you're concerned about, are these cases where, say, a proof is invalid or something was encrypted wrong and you would want the client to retry? Or are you concerned about like a connection gets closed and the upload of like a multi-gigabyte message fails partway through?
Mm-hmm. Yeah, thanks, Tim. I think I'm concerned about both, but I think one of them has a nice solution, which is there's a new spec called resumable uploads for HTTP. I think it will be very useful to adopt. This is basically to handle the cases when the connection gets dropped on the floor for some reason. I also concerned about, the reason I'm concerned about the rejection case is because it's quite explicit in the spec that the reports can be rejected, right, on the upload request. They say, you say a lot like what cases we can reject that because the timestamp is incorrect. So essentially the bulk upload functionally is the same as uploading n reports at the same time. So if any report gets rejected and the spec prescribes us to inform the client that the report is rejected on the upload path, then it needs to be handled on the bulk upload case as well. And it gets more complicated there because it's not just a single report, but there are many reports that may be rejected. Nothing prevents a client from submitting 1 million invalid reports in this case.
So I like the idea. I didn't realize that there was already some work at IETF about resumable uploads. I like the idea of using that. I was going to say, I was alluding earlier to like, you might do something akin to S3 multi-part uploads, but even better if there's already something that that might be pretty far along as a draft somewhere. So, okay, yeah. Definitely we should use that if it's like ready. Now, right, the other thing was, okay, so the rejection cases, right? Like a bad timestamp or a bad proof or wrong encryption. What I would have to ask is, all right, if an upload fails because like the connection gets closed, then it's quite obvious that, yeah, the client should retry the upload because maybe this time the bytes make it. Great. But suppose the report gets rejected because the timestamp is bad. Like, do we really expect that the client will like autonomously take action to resync its clock and then retry the upload? Or if the proof is bogus, then like more than likely what that means is that the client was trying to subvert the protocol. Like, okay, sorry. The reason that we bother to indicate errors in a protocol like this is so that the recipient of that error can look at it and like try something different. And I think our conclusion on the upload path is that we don't actually expect clients to like retry uploads. So I wonder if that might work out here, right? Because like, again, the failure modes are likely to be a client whose clock is hopelessly misconfigured or a client who's trying to inject garbage into the aggregation. And yeah, it's not obvious to me that there's a viable retry path for that.
Right, but there is also a duplicate exception, duplicate error, right? When someone tries to submit the report with the same ID twice for the same task, right? I think it's a legitimate case here because some reports that are getting processed by the leader and the connection gets terminated may finish processing and client doesn't know about them. So the only path for them to find out is to try to submit them again, right? So there will be some lag between like how many bytes were confirmed by the leader and how many bytes were actually committed to the system. So, and the delta, it can be like arbitrarily small, but as long as it exists, clients may run into the situation when the reports get rejected with this. And I agree with you, they probably can't do anything because the currently report rejected error doesn't tell much about this, but at least they won't try to submit that report again. I think that's the thing that we probably need to handle.
Okay, that makes sense. Certainly that's something we'll have to chew on as we design a solution to this. I have more thoughts, but I think it'd be more productive to let others speak, and some of this stuff we can get into as we review changes. Thanks.
Sure. Thanks,
but to sum up, once again, I support doing this in DAP, and I think we should pursue it.
So my question is, so I guess what's interesting is that you're suggesting that the volume of the request is going to be much larger than anything else in DAP. And I'm wondering why that has to be the case. So the way aggregation works is you could, in theory, put all reports you want to aggregate into one aggregation job for that entire batch. But normally what you would do is like divide it into smaller aggregation jobs and then run those in parallel. I guess like taking a step back, I'm wondering if we need to do anything more besides like asynchronous handling of upload requests, like kind of like the way we do everything else in DAP. Would that be enough?
When you say asynchronous, what do you mean by that?
So what we do, what the semantics is today is like, I get the request, I am responsible for handling that entire request. So if the client gets 200 okay, that means the leader is chewing on it, and the client's going to pull the leader until it's going to pull the leader until the leader like finishes that upload request. That would be the idea.
I see. I think functionally, I think it's the same thing. It's just the management of the upload would be a little tougher for the client because they need to keep track of all of these. I think it's just ergonomics, like at this point, like how ergonomic it is to do that. It feels like
what I'm driving at is it would be nice if we didn't have to do something special for upload that we don't do anywhere else, and vice versa. It would be nice, like kind of following what Tim was just talking about in his section, like we should try to unify how APIs work across the whole protocol. So I guess I would probably object to doing something like I don't know what to call it. This someone did provide a link here in the notes. It's whatever, a resumable upload.
Yeah, this one.
Yeah. I mean, for one thing, that's like not in like everyone's HTTP stack. So like, if it's Cloudflare, it has to be a feature that lands in an Nginx for us to be able to turn it on. So there's that sort of lag before you can actually make use of it. So that's something to keep in mind. Basically, it would be nice if I think like, instead of a request being 4 gigabytes, split it into like chunks of hundreds of megabytes or something like that. And you can maybe even parallelize those if the leader's beefy enough, which it should be. I think that's a better way to go.
Mm-hmm. Yeah, I think this spec, at least, what's nice about it, and I like the idea of counting number of bytes that you submitted rather than like actual enumerating reports. But it does have a drawback, and I think they explicitly mentioned that here, that the concurrency is off the table. You cannot submit multiple of them because the way it works. So I'm not particularly married to the idea of using this. It's just something that I wanted to explore and just simply crossed my mind. Martin pointed me to that, and I wanted to see that. But I think async, in terms of implementation, I'm also a big proponent of the idea of reusing the existing stack as much as we can. In terms of like endpoints and providing various ways to clients to upload their data more conveniently, it feels useful to have this opportunity in the spec to say, like, if you have a large chunk of data, you don't need to worry about like chunking and splitting and parallelizing is like doing a lot of client-side complexity there, because there are way more clients than the server implementations. We can just use the streaming uploads and see if it fits your use case. And if it doesn't, the option of like opening tons of connections and trying to multiplex the data through them might be for you if you want to do it in parallel, really, and you have the bandwidth. So I think this approach is basically, we think about collectors as a like single entity, like a single host. You cannot go more than the single host bandwidth for this upload. So concurrency probably is not going to play well here. But if you have many collectors, they can definitely upload things in parallel. That is my current thinking. How this batch bulk upload would be used on PPA.
Hi. Okay, a few thoughts. I think resumable uploads is probably not relevant here. My understanding is that it's primarily useful for cases where you have unreliable networking between the client and the server. And in the cases we're talking about, we either have clients who are sending a single report over an unreliable network, or infrastructure clients who are sending very large reports over very reliable networks. So I don't think we need the complexity of resumable uploads. I do think there's an interesting design question that comes in here about atomicity. Essentially, it seems to me that it's going to be important for each batch that I upload to either have a response that tells me this entire batch is going to be processed. Maybe some of them will be rejected, but at least they'll be processed. And if they are valid, they'll be included. Or a response that effectively says this entire batch is not being accepted, is not being processed. Otherwise, if I'm looking at the collector results at the end, it will become very confusing about which reports are actually aggregated into which results. But that kind of atomicity probably means that you can't process uploads in a streaming fashion. Each batch upload that reaches the leader needs to be held in memory or in some kind of storage in its entirety until it's fully uploaded, and then it can be processed. So like the sequence is like upload 200 response, and then we can start processing the batch. We have to buffer it. In turn, that means that you might need to agree on a maximum size between the uploader and the leader, because otherwise you're potentially asking the leader to buffer an unlimited size block. So I think those are just some ideas for you to chew over as you're working on this design.
Okay, so I'm not sure I agree with the idea that collector and servers will use reliable network, because I think, at least the way we see it on the PPA side, the collectors and helpers will be definitely in different data centers and likely connected over the public internet for these submissions. They won't be.
We're talking about, connections, measured in gigabits per second at least, over, fiber infrastructure networks, not last mile consumer networks that are likely to cause you to lose your TCP connection.
Right, but it still feels like a very possible scenario that the connection fails.
If connections fail 0.1% of the time, then retrying your entire batch costs you 0.1% total overhead. So I don't think that we need to optimize too hard for that scenario.
Okay, and the second point was to limit the number of reports we can upload. We have this conversation internally. Should we do it or not? Not internally. It's in the spec. It's in the issue. I'm not sure if it's any different from like calling the bulk upload report one by one. Like, why do we need to strictly limit? Why do we need to buffer? Sorry, the question is like, why do we need to buffer everything in memory before we can start processing them?
Right. That's the key question. And I think the answer is if the upload hasn't completed, the leader doesn't know that the upload will ever complete, which means it potentially could start adding entries to the aggregation job without any way to signal back whether those entries actually were added to any aggregation job, which makes it hard to understand the results in the end, like what reports were even included in this aggregation job.
But does it provide this guarantee for single uploads? If it's a 200 OK, that means that the job is added.
Well, if it's a 200 OK, it means your report will be processed.
Okay. Yeah, let me think about it more.
Okay, I'm not sure if Chris is actually in the queue, so
Go ahead.
Go ahead. Thanks, Chris. Right. So yeah, I wanted to plus one to Ben's observation about atomicity. I think one thing that's we have to be cautious about here is you don't want to conflate the operation of like uploading a large object to a server with sort of the DAP level notion of I'm going to process some number of reports. And yeah, I think Ben is exactly right that for reasons of atomicity, the server would have to wait until like it gets some explicit signal from the client that like, yeah, you've gotten the entirety of the batch that I want to send you. The prior art to look at here, I strongly believe, like this problem has been solved before in a massive scale in AWS S3 and like competing block storage, object storage products. Yeah, so S3 has a solution for this. What is it? GCP's Google Cloud Storage has a solution for this. The S3 thing, they define their own XML API, and in Google's case, they use a thing where like you use range requests to indicate like, hey, I'm sending you bytes like X through Y of the object. But in either case, the model there is that like you essentially create an upload session, and then you're going to make subsequent requests telling the server, hey, here's chunk number 8 and then 9 and then 10 or whatever of the object I started uploading earlier. And then eventually you tell the server, I have sent you all the chunks. Now you can assemble them into an object that might be like semantically meaningful to something higher level. So yeah, that would be the opportunity. So that's why I think you would avoid having this like intermediate state where the server did process like half of the things in the, I'm not going to say bash because we use that word in too many places in depth. Half of the reports in the bulk upload, but not the other half.
Yeah, I actually worked for S3, so I know what you're talking about. You're talking about multi-part upload, and internally we heard a lot of complaints about this API, and I think I consider it to be a heavyweight for this use case, because it, as you said, it does require like 2-point commit or something. You initiate the session, you carry the session token, so both sides need to manage the session. You manage the uploads, and both sides need to provide enough bandwidth capacity for these uploads. And then you do this atomic commits. And if any part fails or this commit file phase fails, then you basically need to start from scratch. And the reason I didn't consider this for this specific use case, because the individual item that we're trying to upload here is relatively small. So I don't think in a multi-part upload, yes, you do want to split your very large uploads, but you still want to make chunks significantly large to utilize bandwidth properly. So it doesn't seem to me that there is like exact analog of the multi-part upload and bulk upload in this case, but I could be wrong here.
Yeah, I agree with Alex. I don't think that we need a multi-part or multi-request sequence here. I think that we can treat each put as the atomic unit, which my point is just that I think each put needs to be buffered before it can be processed. I can't process the first report in the series until I've received the last report in this request, because I don't know if I'll ever receive the last report in the request. And I think we need to have a coherent, like, upload succeeded or upload failed that applies across everything in the request.
Right. I think this is a good question for the group. Maybe I want to ask you guys about, because as we discussed before, bulk upload and parallel upload, at least in my head, they're the same. If I'm the client, I'm submitting 1 million uploads, right, at the same time to the server. It's my expectation that I don't have a guarantee from the server, so all of them or none of them will be accepted, right? It's still possible for the server to accept some of them, process some of them, and reject some others, and fail on, I don't know, third part. So from that perspective, at least on the collector side, on the PPA spec, I don't see this as a strict requirement to DApp to reject, to make this bulk upload atomic. We do want to know if something failed and we need to retry, if something we didn't submit, but I don't think we need DApp servers to provide us with information that, with the guarantee that, please send us all your billion reports and we'll hold them onto memory and we accept all or none of them. I think it's perfectly fine to accept some of them and we can just retry the remaining ones.
Yeah, I don't think I have much to add there. I think, yeah, I think I just wanted to express an opinion about whether to do this in DApp. I currently don't have a strong opinion. When I read your PR, I noticed that there are kind of like, we have to kind of tweak how things are, especially if we're going to support the common extensions. There are like some edge cases that we have to work out. So I don't think this is, depending on what we want to do with this. I think we still need to do more work in any case. What am I trying to say? I absolutely want to make this happen. I'm not sure we should block DApp on it. If we think, I think continuing to work on the PR is helpful, because we'll get a sense of, like, if there's like core protocol logic that we need to change to make this work. I don't think there is, but yeah. Yeah, I think that's it. Other than that, like, I'm also skeptical about the streaming design. I think it would be, yeah, that's it.
Yeah, I think it's
not super helpful.
It's worth working out the details, and we definitely don't want to block you folks from moving forward. To me, it feels an incremental improvement rather than breaking change. I think there is a consensus here. If we can make it work, it will be just a new functionality on the new version of DApp. So we are totally, and we don't need it like yesterday. So we should be okay, like continuing working on the PR and getting it into the DApp spec eventually.
Hey, this is Sean here as an individual. I also have an opinion. I don't feel this is something DApp should handle. It feels like some kind of engineering work can happen on the client side. I don't have a lot of background of the original requirement you have, but it feels like your client is not really the real client. What you have is an intermediate or a proxy that has a lot of data, and you have some restriction that you cannot send a parallel submit to basically mimic a lot of clients submitting in parallel. I feel this is something maybe should be solved on the client side instead of having a new API or a change of workflow to handle in DApp.
Yeah, I think there are two goals why we're trying to squeeze it in as a server API. One is efficiency, because the clients can definitely submit all this, or intermediates can submit those reports in parallel, but they will duplicate a lot of information across these reports and will be submitted many times. So that's the efficiency gain that we try to get out of this. And second, depending on the implementation, submitting those reports in parallel may mean more cost for both sides, right? If it's I don't know, a stupid way to submit things, let's say, open an HTTP connection and you submit one report and you close that HTTP connection, that's going to be wasteful. And depending on if it's not prescribed by the spec to support that, then we may just end up wasting a lot of resources to manage this. So I think the goal for this API is not to provide more correct functionality, or it's just purely efficiency.
Okay, I think we have enough time that we can move on to the time permitting section. And talk about ECDH PSI.
Hello Ben, hello all in PPM. Thank you for leaving time for my presentation. And here I want to share my presentation. Okay, can you see the presentation? Can you see the presentation?
Slides.
Okay. Now let's begin. I'm Yuchen Wang from Ant Group, and today I want to share our draft of ECDH PSI on behalf of my colleagues Wenting Chang, Yufei Lu, Chen Hong, and Jin Peng. Okay. First, I would like to introduce the status of our proposal, ECDH PSI. We have submitted this draft since IETF conference of 121, where ECDH PSI stands for elliptic curve Diffie-Hellman PSI, where PSI stands for private site intersection. In PSI, two parties with data size SA and SB can calculate their intersection without giving out the records that do not in the intersection. PSIs mainly focus on application scenarios between enterprise and enterprise. In our opinion, we think that ECDH PSI may be of interest to the PPM work group. It's a simple and efficient privacy-preserving protocol, and its security is based on well understood Diffie-Hellman style assumptions. We also believe that many other privacy-preserving technologies, such as MPC and FHE-based solutions, may also be consistent with the PPM charter. And we have received very detailed and valuable comments and suggestions from Christopher Patton and Thomas Pelning. Thank you, Chris. Thank you, Thomas. And these suggestions are very helpful. We have considered all suggestions and comments from CFRG and PPM and released a new version in the following link. I will focus on the implementations and the use cases of PSI and ECDH PSI. Currently, we found that PSI schemes have been widely implemented by the industry, as we have seen that many major vendors have implemented their open source PSI toolsets, most of which includes ECDH style PSI, such as Meta's Private ID, TikTok's Pet Ace, Google's Private Join and Compute, and Secret Flow PSI from Ant Group. Also, PSI schemes have been used in a lot of application scenarios. Here are some examples. The US Department of Education used PSI to match student information between two different internal offices. And Microsoft leverages PSI based on homomorphic encryption to detect leaked passwords without giving out the password in plain text to the server. Also, Apple PSI system detects CSAM content while keeping the legal content private, where CSAM stands for child sexual abuse material. In another case, in Italy, ISTAT, which is Italian National Institute of Statistics, and the Bank of Italy, perform PSI to match the text code as primary keys of different database tables. In another document published by the United Nations, which is titled by the United Nations Guide on Privacy Enhancing Technologies for Official Statistics, also describes some applications of PSI. Anyone who is interested in this topic can refer to that document. And here are some, and here are some use cases of the protocol of ECDH PSI. As shown by figure 1, two service providers may need to compute the intersection of some statistical information, such as the cardinality of the intersection for their common customers. As shown by figure 1, there are two service providers, SPA and SPB, having set A and set B. They want to execute the ECDH PSI protocol since the data cannot be shared directly due to legal restrictions. And they calculate a common site and use the common customer or property site from both service providers for other business purposes. Some typical application scenario, including joint marketing and the promotion of dormant credit card users, and matching the blacklist maybe between different banks. Currently, in China, many service providers have adopted our protocol of ECDH PSI, such as Taobao, Alipay, and ByteDance, China UnionPay, Bank of Communications, and the Bank of China, and most of which are banks. Here, I will briefly introduce the protocol specification. ECDH PSI stems from the private matching protocol proposed by Meadows in 1986. It's a Diffie-Hellman style PSI with elliptic curve parameters, where records are converted to points on an elliptic curve with hash-to-curve algorithms, and masked by the secret keys of both parties with scalar multiplications. As shown by figure 2, if two records RA and RB are the same, they will be masked to the same point even after the joint masking process. However, if they are different, they will be masked to different points, but a participant cannot recover RA or RB since it does not know the corresponding secret key, which are SKA or SKB, which means the matching private and secure. Here is introduction to the security model that we considered for the protocol, which is always under discussion. Commonly, ECDH PSI is considered secure only in the semi-honest model, but the malicious setting, as suggested by Chris, is seldom considered. We believe that the malicious attacker still cannot recover the original record that do not in the intersection, but it can indeed obtain some additional information, such as the cardinality of the intersection of SA and SB. So our draft considers the following potential attack scenarios. There are such as the mask key is used as an ECDH oracle, also suggested by Chris in the semi-honest model, and the side channel attack in the semi-honest model, and a man-in-the-middle attack where attacker can finally obtain the cardinality of the intersection, which is in the malicious model, and finally a replay attack described by Cui and Yu in a research in the malicious model. Here are some minor technical details of our of our protocol. First, we believe that the root cause of malicious attacks is that the attacker can use the masked message in one session to another session. And to solve this problem, we banned the ECDH PSI session to the underlying TLS session. And by utilizing the TLS channel bounding mechanism described in the RFC document of channel boundings for TLS 1.3, we exported the key material EKM from the underlying TLS session and we used the EKM in the hash-to-kill procedure so as to solve the problem of malicious attackers. Besides, we also designed a truncation mechanism to reduce the overhead of data transmission. The recalls in the second round can be truncated as no scalar multiplication will be performed after that round. And we use key duration function, KDF, to truncate the binary representation of EC points and calculate the false positive rate with birthday bound. And here are some references for the open source implementations of PSI and applications of PSI and some research articles. Okay, that is all for my presentation. Thank you very much for listening. I'm Yuchen Wang from Ant Group, and if you are interested in our in our draft, you can find me with my email or in the PPM group. Thank you very much again.
Are there any questions about ECDH PSI? Chris?
Yeah, I just wanted to say I think this is in scope for something that PPM can do. The protocol is a lot simpler than DAP. It does a much more narrow thing, which is good. I think if we adopted this, I think we would want to probably see more security analysis. I'm not aware of a paper that looks at like this simple of a PSI mechanism in a more malicious security model. I could be wrong about that, but I think that could, I think that's all that we would need to see this be an RFC. I think it's simple enough, and I think there's use cases for it. So I think it's something we could work on.
Okay, thank you, Chris. For the problem of malicious attackers, as far as we know, there does not exist a security proof, but there are other security proof for similar constructions, such as the OPRF, and we could consider to extend those proofs. That's it.
Yeah, that sounds promising. IETF uses OPRFs in a lot of different contexts, so that's something we actually know how to use pretty well.
Okay. Okay, we will consider this in the future.
So, as chair, as a matter of process, if you look at the charter for PPM, it was written to pretty specifically to try to develop what became DAP. And so I think we would have to consider whether this actually fits the charter of PPM. I don't think that's a serious concern for this draft, because if it's not in charter, but the IETF is interested in the work, then we can alter the charter of this group or find a different group. So the question to focus on is whether this is interesting to the IETF. And I think that the number one question the IETF generally raises about new work like this is whether there are multiple interested implementers who would like to interoperate. So if you can find multiple parties who would like to use this protocol with each other and would like to standardize it, then I think you're on good footing.
Okay, thank you. Currently, there are a lot of implementers that have deployed this protocol in practice, and we will also invite them to participate with IETF's conferences.
Yeah, that's great. Yeah, and just Ben's absolutely right. The other thing is, if there's an do you have an implementation of this protocol that it's open source?
Yes, at least as far as we know, the projects that I have listed here. Here there are a lot of PSI open source PSI schemes. Most and some of them implement ECDH PSI, but they are not the same as the specification, major because they use different hash to curve, not standard hash to curve algorithms. I think the standardization could make the implementation the same, and they could interact with each other.
Yep. Yeah, that's great. A great place to start would be to implement the specification that you have in the draft.
Mm-hmm.
Hey, thanks for the nice presentation. I just want to add that kind of in support of a similar line of work to this PSI, in the W3C we've looked at sort of maliciously secure OPRFs for sort of the join stage that use the three-party malicious honest majority setting. So like if there were some sort of like generalization to sort of doing PSSI and multiple threat models, that might be something that we could, think about collaborating on for drafts and so forth.
Oh, thank you. That's true. I think we can collaborate in more respects. That's true. That's true. We have some, but that we have a lot of in common.
So this is Deb Cooley. I'm the AD for PPM. So if all of these implementations already exist, why do you need a standard?
Because as I explained above, they are, although this implementation already exist, but they are different, majorly because they use non-standard hash to curve algorithms, and their data formats are different, which makes them hard to communicate with each other. For example, if two companies use different open source implementations, having different algorithms and different data formats, they are hardly to compare their data records, and they are hardly to match their records privately. And so we think the standardization is necessary so that we can make every open source implementation the same, so they can talk with each other.
So you need interoperation, and they don't interoperate today.
Yes. The running ECDH PSI needs interoperation between different enterprise, between different service providers, but currently it is hard. It's a hard task since different implementation have different features.
Okay, thank you.
Thank you very much.
Kenneth, you're up. Kenneth Odo, we don't hear you.
Yeah, so I'm asking, is this a PSI algorithm quantum safe, post-quantum safe, or does it only work for the classical cryptographic cases?
I hear you. It's a classical safe scheme, as it only uses standardized elliptic curve parameters it's not quantum safe.
Okay, okay.
Clarification on that. Is it vulnerable to after the fact decryption attacks? Can I reveal the contents of the private set if I can store one side of the communication and process it if I can break ECDH later?
If you can, if you are an attacker that can break ECDH, I think you can definitely break its privacy. That means if you can break ECDH, you can definitely see the thing in the intersection or not in the intersection. But yes, that's the security basis of our scheme. We assume that the elliptic curve is secure. However, if the curve is not secure, anyone can break this scheme and see the private records. That's right.
Okay, thank you. All right, that is the end of our session. Thanks everybody for the great participation. And I look forward to more progress on the DAP draft.
Thanks so much.
Thank you.
Bye, everybody.
Bye.
Bye.